Okay, so you already know something about the mathematics, like applications of mathematics. You have seen some, but I will once again I will talk about why mathematics. Uh, you will definitely say, okay, you will do mathematics for this class. Maybe you will appear for IOQM, RMO, INMO. So there are lots of mathematical exams. Maybe it will help for IITs, the JEE exams also. But other than this, like other than the career, you may not, all of you may not choose mathematics as your career, right? So other than the career, like why you should learn mathematics? I also feel that learning mathematics is also important even if someone who does not choose mathematics as a career. So there are few reasons for from my side. One is the logical reasoning. So we need to develop logical reasoning. This is required in day-to-day life. Like we have several applications where the logical understanding is very much important, right? So this actually mathematics actually helps you to develop logical reasoning and right proper understanding of logic. This is very much important. How we can develop in terms of the mathematics point of view, like if you study mathematics, how you develop the logical reasoning. What I will recommend that whenever you will see some problem or some solution, you try to understand step by step, each step very slowly, see like whether the how these steps is derived from the previous step, right? So all steps, even if it looks simple, you have to be careful. Suppose there is a step, we have AB equal to AC, and then we write B equal to C. Is it fine if I write like this? What do you think? If you don't think it's fine, it's not fine, then why do you think it's not fine?
Because we ignored the case where A equals to 0.
Okay, so what you said that correctly, that we have to be careful about whether A is 0 or not. So we can write this, if we know that A not equal to 0, maybe from the previous steps or somewhere we know that A not equal. So this A not equal to 0 is the argument I am giving here, the logic I am giving here to derive from this statement to this statement. So this is just one simple example, but everywhere you have to be clear about each step, like why this step is true. Okay. Okay. So this is one thing you must have. Then the second point is also important in not only for mathematics, again like for the real life. You should ask question. So mathematics actually somehow help to ask question, or maybe the right question. Right now you can ask any question, whether it's right or wrong or silly, because that is the way you will be and you will be growing your ability of asking right question. Okay, one cannot ask the very first question is very important, right question. You can ask any question, even if it's a silly question, you just ask. So sometimes some may feel that okay, should I ask this question? It looks so silly. But how does it matter if you ask this question? Maybe after you are asking that question, some of your friends laugh. But that's just you remember, like after 20 years or 30 years, like for me, did I remember like at in class 12, I asked that question and my all the students laughed at me. No one remembered this in your life. Just ask question. And if you ask questions in the class everywhere, maybe in the beginning the questions might not be good, may not be relevant, or maybe important, but that will help your understanding. Your understanding will be improving. In fact, your question, you're asking the questions, right questions. That type of that type of things also will be improved whenever you ask questions. So right questions, asking right questions is definitely important, and this is nowadays is very much important even for the social point of view. And the another important thing is that you must know what you must know what you know or what you do not know. That is also important. Sometimes I see someone, okay, I did 10 questions, I did 9, 10. Okay, wow, great. And you see the results, he got maybe 70. So each question carries 10 marks. That means he or she didn't judge correctly whether he or she did correct answer or not. There is a gap between understanding, but between understanding of between his or her understanding, right? Like he's thinking, okay, I'm right, but actually he's not right. That's also important. And how you can check, like what should be the steps for that, what you should do for this particular thing. Okay, whatever you understand or whatever you think that you know, you may cross check or verify with your friend. Maybe that could be one way. Like, okay, I think this looks like this, do you agree with me? Okay, he can say, no, I don't agree, this cannot be like this should be like that. Then you can have an argument, cross argument, and at the end of argument or conversation, you will know actually what you know, or possibly it might be the situation that both of you do not know, but you know what you don't know. That's also important. It is not a bad thing that if you don't know something, even if you ask some question, if I don't know, I will say, okay, I don't know, I will check it and let you know later. Okay, instead of giving a wrong answer, incorrect answer, better if you don't know, you don't know. Just say that. Okay, so these are the three things what I believe that if you know mathematics well, you will develop these three things. Okay, now let us come little more technical things. So first thing I would like to discuss the percentage. That's a very simple arithmetic we all study. Okay, the percentage. So whenever you have a percentage or any statement which involves percentage, there are three things actually: A, B, and X. What are these three things? That we will have a one thing which is the, say, A, and B is the X% of A. So there will be a statement like B is the X% of A. Although the statement may not appear as like this, like more obvious here, you will see some statement where there will be B, A will be hidden. X will be more clearly visible, okay, 5%, 10%, but B and A somehow is obvious from the statement, or we have said something in the previous statement. So you have to identify what B and A, and once you know what B and A is, then what is the formula? The B equal to A times X by 100. Right? And then whatever questions you ask you. So we must remember that percentage does not accumulate in the additive way. Say, suppose you have some book and you have some discount. The seller is giving some discount, say of 20%, and after 20% discount, he is giving another 20% discount. Is it a 40% discount? No, right? So it's not you can't add, right? So this is a simple feature you should remember. Okay, and another thing, like, okay, there is a price of the book, but what seller has done, he increased the price by 20%. Okay, so once again, like when I say they increased by 20%, what it means, like the B, what is B, what is A, X is 20, right? So if I just to test whether you understand this thing or not, so when I say that there is a initial price of the book, but the seller has increased the price by 20%. What it means in terms of A and B? What is A and what is B? So A is the original price. B is the increment, not the new price, right? B is the increment, like what what extra price I have added on top of A. Okay, and X is 20. Okay, so I am the seller. I have increased the price by 20%, and then I make a 20% discount. Will it be the original price? What do you think? It will be higher, smaller? What about L? Someone says higher, lower. So everyone says it's not equal. Okay, I also agree. So as I told already, that like it doesn't add like 20%, 20% doesn't make 40%. Similarly, when you increase the price by 20% and then you reduce by 20%, the discount, you are giving discount by 20%, it doesn't go to the original price, but will it be higher or will it be lower? How do you check quickly?
Example.
Yeah, and what example you will take?
Say
You,
huh? It will go lower.
no, just yeah, it will go lower. So that just to verify that, just take the 100. So this type of percentage problem, to see what is happening, you can take an example like original price is 100. When you increase, it will be 120, and when you decrease, it will be like you have to decrease 24 rupees, right? Now it becomes 96. So it's less. Okay. Okay. So this is the simple percentage things. So now I'm going to show some interesting table. Okay. So let me write down what table is, and then I'm going to explain the values. So this is called treatment. A and B are, there are two types of treatment, and this is a kidney stone. This is a real life data I have taken from internet. So there are some small kidney stone and some patients have large kidney stone. Okay, and we have 93%, 73% recovery, or the treatment is doing well, like for that much percentage people. Okay, and the total is 72% and 83%. Okay, now let me describe what this table means, like what are the values of this table means. Okay, so there's several people having kidney stones. Okay, and there are two treatments we know: treatment A, treatment B. Okay, and there are kidney stones have two categories. Some patients have a small kidney stone, some patients have a large kidney stones. We have two categories, and for some patients we apply treatment A for even for the small, and treatment B, and similarly for large, even treatment A and treatment B. So treatment A is applied for both type of patients, right? And these are the results we obtain. That means that 93% of patients who have a small kidney stone and applied treatment A and recovered. This treatment works well. Okay. The remaining 7% definitely doctor did something else or some that we don't know. But just to analyze the treatment A and B, how it works. Okay. And similarly for others. So do you think this table looks good? Any question on this table? As I said, you must ask question.
How the total percentage has
of A is so less.
Uh-huh.
How the total percentage of A is so less, 72%.
Okay, so you are saying that how this total percentage becomes 72% or so less than this, right? Okay, so if I say instead of 72%, if I say it's a 78%, then is it okay for you if I just say 78%? So you said 72% doesn't look good. You are asking that question, and in fact you are right. Your question is valid. It's a good question. Okay, but now we have to move further. Okay, the 72% doesn't look good here. Then 78% maybe, but it's still low, right? 78% is still low. Yeah. But
treatment B, it is low. But treatment B has both lower percentages than treatment A in small and large kidneys. Still, the total percentage is more.
Yeah, so you are making another question. So what he was saying that, okay, 78% looks okay in treatment A, but treatment B look all the B is performing good. Sorry, A is performing better, right? A is performing better over small as well as large kidneys. But if you look at the total, A is not performing good. B is performing better. What is happening? So you can ask question here, right? Okay. Before going to answer this particular question, first question I just I have to resolve the first question that we say that 72% is not possible. Actually, 72% is not possible. We can have a mathematical explanation that 72% is not possible. Why? So you have to understand what percentage means. So 93%, 73%, they are actually, if you just think that 0.93 or 0.73 as a fraction point of view. So 0.93 is a 0.93 fraction of people got well after treatment A, and 0.73 fraction got well, right? And this one is a total, and this total fraction, and that will be kind of a weighted average of these two. It has to be a weighted average. So in particular, the actual value is like 821 out of 87 here, and 192 over 263. These are the actual value. Okay, and if you add, then you get 273 over 350. Sorry, 350, not 300. Okay, and this 270 by 350 basically is a weighted average of 821 by 87. You multiply by 87, and then you multiply by 263, and then you divide by 827 plus 263, which is 350. Now, weighted average of two value should be in between the values. It cannot exceed the maximum. It cannot be lower than the minimum. So that's why the 72%, definitely there is a mistake, mathematical mistake or typo. You just raise the question rightly, and it's not about why it's so low. It's about because of this is not in between this. Even if it's 73.5, you may be okay. It could be okay, right? Okay, so this is one question is answered. Now the second question. You are saying, okay, 83%, how is possible? I am saying it is possible because it depends on the denominator. So the actual value is 234 over 270 here and 55 over 80. If you see these two values, the 87% and 73%, you see there are lots of patients are under treatment B for small and lots of patients for under treatment A for large, right? So they actually dominate the value. Actually, they give a kind of they actually their weightage is more compared to others. So their weightage is like here you have 87% and here you have a 73%. That's why you get a better percentage for treatment B compared to treatment A. Okay, so yes, you must ask question, and at the same time you must try to have an explanation behind this question. Like if in case it is okay, then why it is okay. First question is not possible. You rightly pointed out. Second is actually possible, but the explanation is by looking at these two values, 87% and 73%. They have a higher weightage. Okay, so this is nice example about the percentage. Now let's ask one more question. Okay, that's not about the percentage. Okay, so you know orchestra. Like the orchestra, there are several players who play violin or cello, right? So the question is something like this. So there is a symphony called Beethoven 9th Symphony. Okay, probably you know it. I am not familiar with this, but just I find this question. But okay, so that is the Beethoven is a famous composer, and he composed this 9th Symphony, whatever it is that I don't know. So question is that there are 50 players. Sorry, there are 120 players. There are 120 players in an orchestra and performing this Beethoven 9th Symphony in 40 minutes. How much time it will take if there are 60 players perform this? So the 120 players, it takes 40 minutes. 60 players, how much time? So this type of question we have seen in arithmetic. Sometimes the question is proportional, sometimes is inversely proportional, right? But what you have to do, you have to understand the question very well. This question, so this is a real life. You have to translate the problem into a real life system, and then you see what is happening there. So if you just think blindly, 120 players, 40 minutes, 60 players, maybe 80 minutes. But is that the answer? What should be the answer? They are playing a particular symphony. It has to be 40 minutes. It doesn't matter how many players are there, whether 60 players or the 120 players or 2000 players, it will be a 40 minutes. Like our national anthem, right? It has some particular time. Like, doesn't matter how many of you are singing. Yeah. So this is just a fun. Like the message for this particular problem is that you have to understand the problem. Don't jump into a problem by looking at, oh, I know this has to be a proportional problem. Apply the proportional. Oh, it's inversion proportional. Apply this. You have lots of tools. Okay, definitely you will apply. But before going to apply, you first see whether this is the right one to apply. Okay, so this problem says about the understanding the problem. Okay, so now I am going to say something interesting problem. Another proportional type of problem, proportional or inverse proportional, is by Lewis Carroll, right? So let me write down this problem. Oh, sorry. So there are 6 cats who can capture 6 mouse or 6 mice in 6 minutes. Okay. The question is, how many cats I need to capture 100 mice in 50 minutes? Once again, this looks very familiar problem, and people say, oh yeah, I know how to solve this problem because it has some kind of a, okay, 6 cats, 6 mice, 6 minutes, then 1 cat, 1 mice, some minute, and yeah, so just do that first. First do that and see what is the answer. So what answer you are getting? Like 1 cat, 1 mice, 1 mouse actually in 1 by 6 minutes. So just do the calculation. Maybe I don't know, these numbers are written wrongly, or it says 50 minutes, right? 6 cats, 6 mice, 15, 100 mice. Yeah. So 1 cat, 100 mice in 100 by 6 minutes, right? But now I need to make this to 550. Yeah. How much I have to multiply? If I have multiply by 12, sorry, multiply by 3. Yeah, so I think the numbers are not right. It was answer was saying 12, so not 50 minutes, maybe something else. That's what I got confused. So the answer was saying 12 cats, so that means there should be something else is there. It's not 100 minutes. Maybe 200 minutes, maybe. Right? Maybe just change this to 200 minutes, maybe. Then it is 200, then 12 cats, right? Yeah. No, this is 50 minutes. 200 by 6 into 12. No, sorry.
100 by 6 into 12.
Yeah, so 1 by 6.
Still 100 only. 100
Right,
by
right.
6 into
So
12.
100 by 6 into 12. That makes 200. Right. So now if you do the same calculations, so here what happens, like we are actually considering that 1 cat capture 1 mouse in 1 by 6 minutes. Right. Now if you calculate this, here we actually assuming the cats are capturing the mice independently. Okay. So now here the issue is about the interpretation of this statement. How do we interpret? Like we can interpret, this is the natural interpretation, and in that interpretation this answer is right. Okay. So there can be other interpretations where we can say that, okay, no, see, maybe they actually work together. Maybe they are working together, means there are 6 cats actually capturing together to get a 6 mice. Okay. So in that case, the answer will be in multiple of 6. Like maybe 12 cats. If you check here in this example, 200 is not multiple of 6 minutes. So you will see that you don't get a it will capture close to 100. Like if I just multiply, say if I go to 12 cats, just a minute, so if you have 12 cats, so 6 cats, 6 mice in 6 minutes. So okay, yeah. So now it is 6 minutes. So you have to add the 6 minutes several times, and 200 is not a multiple of 6, right? So if 200 is not multiple of 6, you can go up to some number which is close to 200 and multiple of 6. Okay, so that means you get like 6 cats. Say what is the number closest to 200? 100. How much you have to multiply?
198, 33.
Huh? 33.
198.
So 6 cats in, you just multiply 33.
Yeah, 33 into 6, so 198.
No, I think we are doing wrong. Yeah, actually we are doing wrong. Can you find out what is the wrong here? We are doing wrong. So let's recalculate. Maybe in the next page. Go to the next page. So you have a 6 cats, 6 mice in 6 minutes. Right? This is a simple problem. Yeah. So if you just do it 1 cat, 1 mice, then it's actually easier. So the question is how many cats required to capture, say, 100 mice in, okay, that number, the minutes I said is 200, that's not right is say 50 minutes. Let's go back to 50 minutes once again. 50 minutes, huh? Yeah. So actually we did wrong. Yes. So can we explain like so what is happening? So these numbers was right. The answer was 12 cats. Answer was 12 cat. But if you have another different interpretations, you will get a different answer. So the message here is that whatever we usually do is right. That's just one cat, one mice, certain some minutes. But there might be a different interpretation of the same statement. So you must ask question like whether they are working together or whether can I have a one cat, one mice in certain minutes. Like cats can work together, the six cats can work together or two cats can work together, then the answer will be different. Okay, so depending on how you group the cats, the answer will be different. But just if you do the usual problem, like what can we explain? Like if you just consider one cat, that what we did mistake, like one cat in one mice in how many minutes? 1/6 minutes. This is okay, right? Fine? Or you have something else? Or no, it's not 1 minute. 1/6 minutes, more, 6 minutes.
One cat, 6 mice, that is
It's not 1/6 minutes, right?
One cat, 6 mice in 30 seconds.
Ulta kar liya, right? This is ulta ho gaya. So it will be one. So 6 cats, 6 mice in 6 minutes. One cat, one mice in 6 minutes. It will be again 6 minutes. Right? One cat, one mouse in 6 minutes. That's why 6 cats capture 6 mouse in 6 minutes. 6, right? And then what we need, how many cats for 100 mice in 50 minutes? So if you increase, so there's an inverse proportional, there's something proportional that you have to be careful, right? So if you increase the mice, so 100 mice, you need more cat, right? So you have to multiply by 100, okay? But before it was 1, but I will also increase the time. The time is now not 6 minutes. Time is now 50 minutes. So I have to divide like 50 by 6, and that is 12. So the answer is 12. So because of the 100 mice, I need 100 cats in 6 minutes, but the time is increased to 50 minutes. So now time is inversely proportional. If you have more time, then you can. So now you divide this 50 by 6, so you get 12. Yeah. So the original answer was right. But what the problem was that how do we interpret this line? Now, if you think this line as they are working together, okay, then you need more mice, more cats. Okay. Even if you think that if you need two cats together, then also you can check. I can give a homework, like you can try. Suppose in this problem the interpretation was like that two cats work together in 6 minutes captures how many mice? 2 cats should capture in 6 minutes 2 mice. 2 cats will capture in 2 mice, right? That's why 6 cats capture 6 mice in 6 minutes. So there are 2 cats, they are working together. After 6 minutes, they can capture 2 mice. Or maybe after 3 minutes, they capture 1 mouse, and next 3 minutes, they capture another mouse. In that way, it can also interpret. Now, if you under this interpretation, if you try to solve this problem, you will get different answer. So that is the nice thing about this problem. So we usually go by simple one cat, one mouse in how many minutes, but that may not be always integers. But minute is okay. Minute I can keep 1 by something minute. But if I think like cat, like it cannot be 1 by 2 cat. It can be 1 by 4 cat, or it can be 1 by 2 mouse. Sometimes you have to keep that in mind because of the problem is coming from the real life. If you just translate the problem in just like a mathematical abstract objects, then this is always we will do whatever we have done. Okay, so depending on the context, you have to revise the thinking. So this is one important example we should keep in mind. Okay, so this is good for the arithmetic. Now I do something little bit geometry. Okay, so I have a right angle triangle ABC where the hypotenuse is 10 unit and the perpendicular from this A is 90 degree, the right angle triangle, and this length is 6 unit. Okay, so what is the area of ABC? What is the area of the triangle ABC? This is simple question, not difficult.
30
Huh?
30 units square.
30 units square. How do you get that? So 30 you get by which formula? Half into base into h. So half into 10 into 6 equal to 30. That's the area of the triangle. Perfect. But I'm saying there might be something wrong here. Can you see is everything is fine? I'm saying no, maybe your answer is okay given the figure. I am not questioning on the formula. But what natural question you should ask given this problem? You should raise your question, concern always. Like what will be your natural query here for this particular problem?
Is the line is cutting it
Huh?
midpoint? Is the line A, the line from A is cutting the BC's
No,
midpoint?
no, I am not assuming that this perpendicular is cutting into midpoint, right? I am not assuming here, right? Maybe in the figure that looks like, but just I drop the perpendicular, it cut anywhere. So this 10 is whole length BC. I am not using this. So this formula is true for always, like for any triangle. For any triangle, not only that perpendicular or right angle triangle. This is H. Sorry, this is B. So this is H, and this is B base. So the area will be delta area is half times B times H. That's always true, irrespective of whether it cuts in midpoint or even it can go outside also. Like this can go outside also. Okay, so this formula is valid everywhere. No question on the formula. This is a very standard formula. Okay, so something else has issue here.
AC is the perpendicular to BB.
AC is the perpendicular to AB. Yeah, so I have given extra information. Possibly this is not required, right? So that might be a problematic. Can you think like AC is a perpendicular to AB? Is it okay? Or the question is, can there such triangle exist? That could be a natural question. The question here one should ask, okay, if the triangle exists, this is the area. Does a triangle exist with this information? Can you check whether such a triangle exists or not? Maybe you can use, let's call it, this is the D. So you can call this as X, and this will be 10 minus X. Perfect. Now what we will do? Huh? Doesn't exist. So you are saying it does not exist. My question is why? How do you prove that it doesn't exist?
Sir, we can use theta like
Which angle is theta? The angle?
sir, BAD.
Angle BAD is theta. Okay.
So 6 sin theta equal to BD.
6. Okay, you are using trigonometry.
Or
Uh,
CAD or 90 minus
So 6 sin theta is how much? So sin theta is a formula that it just says that base, the height by hypotenuse, right? But we don't know the hypotenuse. How do you say 6 sin theta?
You can also take tan theta.
6 tan theta, you can say something 6 tan theta is, or instead of writing sin theta, you just see what is tan theta. Tan theta is x by 6, right? Yeah, you can apply trigonometry, but we don't need that tool actually. Even if, because there is a perpendicular, there is one more theorem which is very useful, right? Perpendicular Pythagoras theorem, right? So, what is Pythagoras theorem?
Base square plus height equals to hypotenuse square.
Yes. So, Pythagoras theorem says that if you have a right angle triangle, any right angle triangle, this is x, this is y, this is z, then z square equal to x square plus y square. We need this theorem only. That will actually give some values. So, we have a x here, we have a 6 here, right? So, that will give AB. So, what is AB?
36 plus 6.
Huh?
36 plus 6 square.
AB is
36 plus 6 square.
AB is 36 plus x square.
Root under 36 plus 6.
Yeah, it's a square root under 36 plus x square. Okay. Now AC is similarly
Under root 36 plus 10 minus x whole square.
perfect. This part I have no issue. Maybe I erase this. Okay. Now you just compute AB square plus AC square. It has to be 100. Just write it down. What you see? You get a quadratic equation. Good. Why AB square plus AC square equal to 100? Here I use the fact the angle A is 90 degree. Okay. So, in general we may not have this. Because the angle A is 90 degree, we have this. So, that imply
Excess 2.
so what is the equation you get? Just write down the equation. So, this implies
X can have 2 value.
no, just first a quadratic equation. What is the quadratic equation? Before going to solution,
X square minus 10x plus 36.
x square minus
10x plus 36
equal
equals to 0.
to 0. Good. So, that just replace your AB square by 36 plus x square, AC square by this value, simplify, you get this. Good. Now, that looks perfect. Now, no issue. There is a quadratic equation. What is the problem here? Yeah, so we know that for a quadratic equation there is a root. For that, there are two roots, and for that you have to look at the discriminant, right? And what is the discriminant here? Discriminant here is b square minus 4ac. So 110 square is 100 minus 4 times 36, which is less than 0. So if the discriminant is negative, what it says?
Roots are imaginary.
So there cannot be any real root. Okay, if you don't know the complex number, just okay. What you can say that there is no real root. That means there is no x. No real x is possible. But x is some real value. It has to be some value. 4, 5, 4.5, something, right? So there is no real root. That means this triangle cannot exist. Okay. But apparently the problem looks so nice, so simple, we just solve. But we see that. Now I can ask one more question here. Okay, there is no real root, fine. But that is because of maybe which value? Maybe if you change some values, then possibly we can have some root. Which value you want to change? Maybe the height. So the information about the height is 6. That might be too big. Maybe we can make it less. Like what can be the value for the height? Now I am calling instead of 6, let's call it h. Okay. So h is 6 is not possible, what we have seen. But maybe h is equal to 4 or 5 or 5.5, some value is possible. So can you find the maximum h for which this is possible? I mean, this triangle exists. So the question now, find maximum h for which the triangle ABC exists. Yeah, so you have to explain why that answer. So someone says that the answer is 5. So h should, the maximum h is 5. So what you have to prove? So what are the things you have to prove? Like what is, if someone claims, suppose you claim that maximum h is 5, then what are the things you have to show me?
That we are getting some real value.
For h equal to 5.
Yes.
For h equal to 5, you are getting the real root.
Yes.
But that's not enough. You have to prove something more. H equal to 5, you are getting a real root. Okay. There are many things to check. So h equal to 5 imply real root. Okay. This is number 1. That I think you can check easily. Just do the same calculation once again. You get another quadratic equations, and that quadratic equation you will see that there is a real root, and that's fine. So I'm not going to go all these details, but what I want to understand, like what are the things you must verify or you must show to have a complete proof of this statement that the maximum value of h equal to 5. You have to understand what are the things to show, right? So it doesn't, it is not enough to just to show that h equal to 5 has a real root. What else you have to show?
It is the only maximum real root. Anything between 5 and 6 is not possible.
So anything greater than 5, not 5 and 6, anything greater than 5, if you take h greater than 5, so this is number 1. Number 2, for all h greater than 5, this is a notation for all, okay? For all h greater than 5, no real root. No real root for x. This is real root for x, right? The equation we get. Okay? That means 5 is the maximum value for which you have a real root. Is it enough? Are we done yet? Or we need to show something more?
For less than 5 also.
For less than 5, should I care? I have to show the maximum age. Suppose for less than, for some age it doesn't exist. Okay, no problem. Or exist. Okay, I don't care. For equal to 5, what was the question? Find the maximum age for which triangle exists. But what you have shown? So you have shown there is some x, you found some quadratic equation, and for quadratic equation there is a solution. That's not enough. You have to construct a triangle. You have to construct a triangle. You have to demonstrate a triangle with h equal to 5 and base equal to 10 and the right angle triangle. And you have to show, okay, look, I can construct a triangle like this. It might have violated some triangle inequality. I don't know. Like, you have to be careful. So just demonstrate a triangle, then you are done. So the final thing is the number 3 is construct a triangle with this. Construct a triangle with h equal to 5. Right? So for that, what you have to show, just you just take 10, you just take a middle point, 5, 5, and then take a perpendicular 5, let's call it A, you join this. So basically, just take a 10 side, the 10 unit side, take a middle point, draw perpendicular, and the length of the perpendicular is again take 5. You get point A, join ABC. What you can show, this angle is 90 degree because this is 5, 5 same, so 45 degree, 45 degree because this is 90 degree, and this is also 45 degree. So total is 90 degree, right? So we have demonstrated a triangle with this. Then you are done. So sometimes we think, okay, we have done it. So many people think, okay, I have done 9 problems, but there is a gap between logic. So after these 2 steps, he thinks, okay, I am done. Because of this gap, he may not get full marks, depending on how the scoring strategy. For IOQM, there is no nothing like part mark because it's just a one answer you have to give, right? There is nothing you have to show. So for IOQM, you will not face this type of problem. But for RMO, you have to write the answer. And if you write the answer, and if you write the first part and second part, and if you do not say the third part, then some part marking will be lost. You will get some part marks. So this is important. So that you have to keep in mind. Okay. Okay. Oh, other side. Okay. Good. Now let's do some logical reasoning. So I said that's why mathematics, and the first point I said is logical reasoning. So in fact, all these problems like the previous problem, you see some logic is there. Okay. So logical reasoning is important, but now it's more like just a logical problem. So we have a three rooms, big room, and in one of the room it contains a car. Okay, you don't know which room it contains car. Room number 1, room number 2, room number 3, and in front of the room it is written something. So for example, in the room 1 it is written the car is here. Okay, in room number 2 it is written here the car is not here. Okay, and in room number 3 it is written that car is not in 1, not in room number 1. Okay, so these are 3 statements are there, and we somehow know that exactly one statement is right. Okay, then where the car is? Or maybe this type of problem, what could be the possible solutions? You can explain what the possible answer for. Okay, here I said some informations. Okay, with that informations there can be multiple answer. Number 1, that, or sometimes we can say that it is not sufficient information is given. Sufficient information is not given to say where exactly the car is, right? So maybe it could be car room number 1, or it could be room number 2. Doesn't violate what are the things, or information might be self-contradicting each other, right? So like I draw a triangle which is not possible, right? So okay, whatever you said is not possible. The car is not actually, I cannot say because your informations are incorrect, contradicting each other. Okay, this could happen. Or there exists one room, actually the car there. You just explain logically from the given statement that, okay, look, because of this, the car must be in this. These are 3 possibilities for this type of problem. So I am not saying which one, whether this has an issue or not, whether these are multiple, it is sufficient information is given or not, or you can actually identify the exact room number. So in addition to these 3, what is given, that exactly one statement is correct. Exactly one statement is correct. The other two must be false. Which one you don't know? If you know which one, then it becomes very obvious. I may not be. I don't know. Anyway, so then can you figure out what is happening here?
So only in third room there is not any comment in any of section.
In third room, there is not enough.
Not enough comment for 1 and 2 that the car is not there. Because 2 says that car is not here.
Yeah, but it could be that you can eliminate that car is not in 1, car is not in 2, and then only option the car is in 3. Okay, so here it is also mentioned that exactly one car in these 3 rooms. This also mentioned. Okay, exactly one car. So if you somehow, like we also do some eliminate the possibilities, right? So in the detective story or all, like we first list all suspicious guys who can be the criminal, and then you eliminate. Oh no, he cannot be or she cannot be, and then it looks like only 1 or 2 options are there. Okay, so you are saying the room number 2. Okay, what is your argument? So someone is saying that room number 2. Any other answer, by the way, before going for room 2? So one detective is saying room 2. Before opening the room 2, let's see any other opinions is coming from others. Room 3. So you are saying someone else is saying room 3. Okay, let's see the room 3 analysis. So can you explain why you think room 3?
So because room number 1 says that car is here. Room number 2 also says about his comment. But room number 3 comment on the room number 1. But there is not enough information for room number 3, so we can comment on room.
No, that's okay. That's what you are saying is kind of a guessing. It's not a mathematically arguing. It's not a logical argument of supporting. So what you are saying that room number 3 does not have the information of room number 3 doesn't have any sufficient, or there is no information about the room number 3, whether the car is there or not. Well, on the other hand, there is some information about the room number 1 and 2, but that does not say anything about the room number 3 has a car or room number 3 does not have the car. As I said, like maybe the other informations are sufficient enough to conclude that there is no car in room number 1, there is no car in room number 2, and it's given that there exists one car at least. So by elimination, the car is in room number 3. So that can be quite possible, right? Okay, so now we move to the other one, like explaining room 2.
We can check for each and every statement. We know that exactly one of the
so we know that exactly one of the statement is correct, right?
Yeah,
so
if we assume that first statement is
correct, okay, that's the right way to proceed. So because there are 3 statements and we know exactly one statement is correct, so we have to go one by one. So check whether first assume that okay, statement 1 is correct. Let's call it statement 1, statement 2, statement 3. So we go by case. So case 1, we assume statement 1 is correct. Right? We assume statement 1 is correct. Perfect. Then maybe it might be wrong because this is one possibility. Okay, so what is happening here? If the statement 1 is correct, then it says that car is here. The car is in room number 1. Good. Okay, it can be. Statement 2 says that car is not here.
But that is also true.
That is also true. Because there is one car. That is also true. Good. So that means this is contradiction. We call that is a contradiction. It's not possible. Good. Then we move to case 2. Case 2 says that car is not here. That is correct. Car is not here is correct, right? So if that is correct, then what happens?
It can either be in room number 3 or 1.
So in that, it says that either in room number 1 or room number 3. Fine. But S1 and S3 are also false, right? So what will happen then?
Yes, so we can argue that if S2 is correct, then S1 and S3 must be false. And if S1 is false, that means 1 is saying car is here, then also it is a possibility.
So if the room,
Yes,
if the car is in room 1,
Yeah.
then S1 becomes correct, right?
Yes. That is a contradiction. So car cannot be in room 1.
Because I'm assuming only S2 is correct. S1
Yes.
must be false.
Yes.
So S1 and S3 must be false. So now under case 2. So assuming that statement 2 is correct, okay, then statement 1 and 3 must be false.
Yes.
So if R1, a car is in R1, then statement 1 becomes correct, which is not possible. And if the car is in R3, then car is not in room 1.
That also becomes true.
So if the car is in R3, room number 3, then the statement 3 becomes correct. Because statement 3 says that the car is not in R1, and that is right. So statement 3 becomes correct, but that's not possible. So case 2 is also not possible. So now move to the case 3, which says that statement 3 is correct. Okay? So car is not in room 1. Okay. Oh, sorry. First,
A student chat.
second statement is true. Yeah.
No. Third.
Third statement is true. Yes. So someone is saying that third statement is true, and I think that's what we are going now. So we are going to the case 3, right? So the case 3 says the third statement is true, and we have to justify that it is actually aligned with this statement, that exactly one statement is correct. So third statement is true. So car is not in room 1. What it means? So it will be either room 2 or room 3. Fine. And then we have to check the other statement. Car is here. S1 says the car is here. That's false. Okay, that's good. And S2 says the car is not here.
That also must be false.
That also must be false. Right?
So that means the car is in room 2, because room 3 says that car is not in room 1.
So room 2. So statement 2 says the car is not here. Means car is not in room 2. That must be false. That means the car is here. So case 3 is actually, we can check that case 3 is coming true, like the statement 3 is true. Okay. So we go one by one, statement 1, statement 2, statement 3. And it could happen that for some other type of statement, you can phrase your own statements, and maybe all statements eventually contradicting each other. Like all possibilities you see that contradicting each other. Maybe the case 3 also see similar contradiction like case 1 and case 2. In that case, you can say this statement, this is contradicting each other. And there could be another possibility, like, okay, for the case 1, it becomes true. In that case, you have a car is in room 1 maybe, and for another case 3, you have a car in room 2. So that means sufficient information is not given. So it could happen like you first try case 1 and then you try case 3. Okay, you are trying case 3 first maybe. Okay, you're just skipping case 2 and you find, oh, I got the car in room number 2, and you stop there and you write, by this argument, the car is in room number 2. I am done. Am I done? Yeah, so it's again an incomplete answer, because there could be a possibility that it doesn't have sufficient information. Okay, so the case 2 you have to check. For case 2 may lead to another answer. Then you have to conclude, okay, this information is not sufficient to say where the car is, either here or there. Right? So that's why we have to continue till case 1, case 2, case 3. Good. So this is a logical reasoning problem. Let's just have to go through the logic behind whatever is given. Fine. Yes.
Statement 3 saying the car is not in room 1.
Statement 3 says the car is not in room 1.
Not saying about is it in 3 or not. And
It is the statement 3 does not say about room number 3.
Yes.
It talks about only room number 1.
Room number 1. And the statement 2 is saying car is not here. It can be in 3 also.
No, so the point is exactly one statement is correct. There are 3 statements. All 3 are not correct. So exactly one will be correct and other 2 will be lie. False.
3 is correct. It's saying that it is not in room 1. It's not saying about that it is in room 3 or not.
So car is not room 1. That means it is either in room 1, room 2 or room 3. Yes.
The statement 2 is saying car is not here. If the car is in room 3, then statement 2 can be correct.
Now, if the car is room 3, then statement 2 is correct. But I already said exactly one statement is correct. That is not possible. So that's why this statement 2 that car is not here must be false, because exactly one statement is correct. So this is also given that exactly one statement is correct. So that's this statement is correct. There is no so I can say, I can make it more complex, that okay, you can consider this as a one statement, then it becomes more complex argument. But here this statement is correct means exactly one of this statement will be true and other two will be false. We don't know which one is true, which one is false. So if we assume that a statement 3 is correct and these two are false, then we see that okay, this looks okay if the car is here. So you just think in this way. Just put car here, put car here. Then check all statement one by one. Statement 1 is correct or wrong? Car is here. Is correct? False. Okay. Statement 2, car is not here. Car is here. False. Statement 3, car is not in room 1. True. So you check one by one all statements and you find that this statement is correct and the other two is wrong. So
can we say that the car is in room 2?
yeah, so that's why we check all the cases one by one. So to say why the room 2, so if you go to the case 3, then you can conclude that it is in room 2. You have to go to the case 3 because the case 1, case 2 lead to a contradiction. You just what you will do, just write it down, this problem, okay, and analyze the case. Actually, analyze all the cases, but the case 3 will give you a final answer. But you have to analyze all 3 cases. Okay, just do it once more at home. Maybe that will actually help, because whatever I am telling you, if you just write down the problems and see once again at home, try to understand by yourself, it will again reveal some more things that what you don't see here. It happens. Like I see some problem, for example, mice problem, cat problem. I saw somewhere, and then once I come here, once I describe the problem, I realize, okay, just that I'm making mistake. Like, so this type of things can happen. Now, if you go at home, you will see something comes in your mind, something which I didn't say. Okay. So just check this problem once more at home. I want to ask one more logical problem. That's a very simple problem. I don't have to write much, but just to note it down. There are 2 persons, A and B, and I don't know. Okay, so A and B, and one person speaks always true, and one person speaks always false. So one person always say right, correct. One person always say wrong. Okay, and A and B, who speaks true and who speaks false, that I don't know. Okay, I don't know whether A speaks always true or B. So I know 2 of you, one of the persons always speaks true. So what I have to do, I have to ask one question to one of them, whichever I like. Okay, I have to ask only one question. Okay, and what I have to know, that there is a road actually. There's one road is going this side, there's another road is going there. You are here actually, and both A and B are in this corner. And you want to know, there's some city, say some city, you want to go to some city. Either this road goes to city or this road goes to city. You want to know which road goes to that city. So what is the question you will ask? One question you can ask to A or B. Or maybe first you can, if you want, you can make it simple first. You can ask 2 questions maybe. I don't know whether it will help or not. Just to, I'm giving more freedom. If you think that if you ask 2 questions, that might be easier, you are allowed to ask 2 questions. Maybe you can ask 2 questions to both A, or one question to A, one question to B. Okay. At the end, after getting the response, you have to surely know which road goes to the city. Okay. You can ask, okay, does this road go to city? Maybe one person. He can say yes, but that will not give any information, right? Because he can say true, he can say false also. You don't know A and B, who speaks true, who speaks false. But you have one more question you can ask. to anyone, A or B. This is easy actually. This is easy. Asking 2 questions is easy. But asking 1 question is a tricky one. So I think you should be able to find out 2 questions answer.
If we have the option to ask 2 questions,
Yeah.
then we can ask 1 question which answer we know, and they also.
So you can ask 1 question whose answer you know.
Yeah, something like how many fingers do I have on my hand?
Yeah.
We
So
can ask that question to both of them, and then we know who is saying the truth and who is saying the
so you can ask a trivial question where the answer you know, whether today is Friday or today is Wednesday. You can ask this type of question where answer is you know, and in that way you actually know who speaks true and who speaks false, and then you can actually ask the question whoever you like, the question you want to know, right? So 2 questions is easy, good, but now we have to ask only 1 question. So okay, I am not giving that much freedom. You don't have much time. You just quickly ask 1 question and then you leave. How we can find, what will be the question? Anyone is online can also answer the question, can give the question also. Post. Someone has answered the question? Can you check? So you all think, yeah. Yeah, so 2 questions is fine. So 1 question. No, not 1 question to each person. So you can ask only 1 question to only one of them, not 1 question to both. So someone is asking whether can I ask 1 question to each person? No. So if you ask 2 questions, you already got a solution. So whatever you said is fine. Yeah. So, but now I have more constraint. I can ask only 1 question to anyone you like. You can pick A, because it doesn't matter to whom you can ask, because you don't know any information. So you just suppose you are asking a question to A only. The question you are asking to A. A can speak true or false.
I might have a question. Which of the road does not lead to the city?
Which of the road does not lead to a city? If we say okay, this road, then how do you do not know whether A says true or false?
So if A says the truth, let's assume if A says the truth.
Let's assume A is a true man. Then
then we ask A which road does not lead to the city.
we're asking only 1 question, right?
Yeah, both of them will ask only 1 question.
No.
Okay.
So that's what someone is asking actually online, that whether you can ask 2 questions, you can ask 1 question to each. No, you can ask only 1 question
to 1 person.
Only one person, and that's all. Okay. You cannot ask another question to other person. No. Then it's actually easy. Actually, you can do the same trick like before. So you can ask the question, okay, today is Wednesday. Whatever it says, you know, true or false. Then you ask the question or the original question to the question you want to know to the other persons. You know whether he speaks true or false. You just reverse if he says false, then we will reverse it, right?
If we are using this road, we will reach the city in 1 month. So
if you ask like that, okay, so basically, yeah.
The time interval.
So what he is saying, like if I ask this road, if I go to this road, whether I will reach to city by 1 month. Suppose he said no, then what will you say?
Because I know that it will not take 1 month. So it means he is saying false.
Yeah, but that doesn't mean that this road may not go to the city. That's also possible. That's why he said no. What you have to do here, you have to involve both of them somehow, because you are asking 1 person's, and that statement may be true or false, that you don't know. So try to involve both of them by 1 question. By the way, so they know each other, that I speak true, he speaks false, that they know. Okay, that's the information is you know. Okay, because they are in the same locality, they know. Okay, so you can ask something like that to A. If I ask the question to the B, this blah blah blah, this question, then what you will answer? Basically, you want to hear the answer of B from A. You got my point? You are not, actually you are asking the question to B, but you want to hear or listen the answer from A, not from B. So the question is, if I ask the question, or if I ask that, say, give a road name. So this road is road 1, this is road 2. Okay. So if I ask whether road 1 goes to the city, what will be the answer of B? I'm asking this question to A. Okay. So A, I'm in front of A, Mr. A. If I ask the question that road 1 goes to the city to Mr. B, what will be his response? Can you tell me? Now he will say either yes or no. Okay. Now the question part is done. Now you have to go to the analysis part. How do you now decode, or how, after knowing the answer, how you should be able to understand which road actually goes to the city? Suppose, so the question is clear. Is there any question on the question?
No.
So question on the question is no. Okay, so you got the question. Now my question is, suppose the answer is yes with that question. Now which road he will choose? So the question was that if I ask road 1 go, or does road 1 go to city? If I ask to Mr. B that does R1 go to city, what would be his answer? I'm asking this question to Mr. A. Mr. A, I'm asking this question. Okay, Mr. A, if I ask Mr. B that does R1 go to the city, what would be his answer? Now Mr. A says his answer would be yes. Now I have to understand and I have to choose the right road. Which road I will choose?
Take road 2.
Okay, why? So the answer, so after that decision is go to road 2. Road 2 leads to city.
Yes.
Why?
So we can again take 2 cases.
Huh?
We can again take 2 cases.
We can take 2 cases.
We will assume that Mr. A speaks the truth.
Exactly. So we'll take 2 cases because we don't know.
Yes.
The Mr. A can speak true or false. But if Mr. A speaks true, then Mr. B speaks false. Right? So let's do the one case first. So Mr. A, so let's take the picture. So Mr. A and Mr. B. Let's assume true, false. This is one case and false true is another case. So in that case, what is the analysis I am writing here? So Mr. A says true, Mr. B says false. Okay, this is a case. So if I ask to Mr. B, does R1 road go to the road 1 goes to the city? What would be his answer? His answer is yes. Right? But now I know Mr. A is true and Mr. B is a false man. So Mr. B definitely will give a wrong answer. Right? So he is saying yes. But by the way, Mr. A actually will be truthful. So whatever Mr. B will say, Mr. A will convey. Mr. A will not change the answer. Right? So Mr. B must say yes. Okay? That's why Mr. A says yes. So here Mr. B must say yes. That's why he said yes. Okay? But because his answer is yes, definitely road 1 is not going to the city. Because he says Mr. B is false. So in that case, the road 2 is the right road. Okay? Now let's see what happens in the other case. If the other case it becomes road 1, then again I will be in trouble. Okay. If it again road 2, then I am done. So here I am asking to a false person. If I ask the road 1 is right road or not, to Mr. B, who is the right person, true man. So he must say no. So his answer will be, actual answer will be no. Okay. But because Mr. A is a false person, he always say false. So whatever Mr. B will say will reverse, change. So Mr. B will say no, so he will say yes. So that's why he said yes. Right? And because the answer is no, and Mr. B is a true person, so R2 is the right road then. Right? So in both cases we see that road 2 is the option. Okay? Okay, good. So now let's do something on numbers. So we have done some good logic and some problems. Let's do something on numbers. So we will play with numbers. So number is the basic things, basic object in mathematics, right? So let us do this game or do this puzzle or the magic. Okay. So all of you just think two numbers, small numbers between 0 and 9. Think two numbers. Okay. Or maybe whoever in online also, you can think two numbers on online. So both persons cannot be true or false. So what I said in the beginning, in the previous problem, that one person is either true, exactly one is true, and exactly the other one is false. So that's why you have two cases: true, false, false, true. We don't have true, true, false, false. Okay. So that is given, that exactly one person will say true and the other person will say false. Okay. So if both persons says true or both persons say false, then it will be a different situation. Then one question will not be enough. Then you have to ask one more question. Okay? Okay, good point. Yeah. Okay, so now just go to the numbers. Just think two numbers, two small numbers between 0 and 9. Okay, everyone, maybe online. Okay, now take the first numbers and double it. The first number, double the first number. Have you done it?
Two different numbers.
Not necessarily. You can think two numbers, but small numbers between 0 and 9. Two integers.
0 and 9 can be taken.
You can take if you like. But don't tell me which number you can take 5, 4, whatever. So first take two numbers, and first number you just double it. Okay? And then you add 5. After double whatever you get, you add 5. Okay? Then you multiply by 5. Okay? So multiply 5. So you get something up to that. Now you add the second number. So far you are doing with the first number. Now add the second number. Got all these 4 steps? Simple. Just do the calculation correctly. Simple arithmetic, but sometimes we make mistake. Okay. Okay, you have done. So now maybe you can tell, like you first tell what is the answer. So someone said the answer is 37. So he thought one number 1 and other number 2. Very simple numbers he thought. 1 and 2. What about you? 37. You said 37. What? So I don't have to say. Okay. Then you?
69.
Huh?
69.
69. Okay. So for you is one number is 4, other number is 4. Both 4. 4 and 4. 60. 60. So for you is one number is 3, another number is 5.
25.
25. You just chose both 0. So he chose both 0. Okay, good. What about online guys? Any numbers? You can tell any number, whatever is. You can write it down. I can tell you your numbers. So if you follow these 4 steps, the first number double, then you add 5, then you multiply by 5, then you add the second number. What huh? Oh, someone got 52. So someone got 52 is not here. Good. So he thought 2 and 7. Just tell me whether I'm right or wrong. Okay? Okay. So the question is definitely, this is like a magic, but it's not a magic. So every magic has a logic behind that, whether it's a stage performance or it is a mathematical puzzle. So your goal is will be to understand the logic behind this. What is the strategy or what is the procedure I'm using to get back the numbers, and why it is working. Just knowing the strategy or knowing the method is not enough. I will not be happy just know the method. That will be kind of a lazy thing. So I don't want to get into mathematics. So just know the method so that I can perform the magic. No, that's okay, but you have to know the reason behind the method, why this method works. Okay, so we have to find two things. We have to identify the method and why the method works. Okay, good. So any idea? Let's see, like by looking at all those numbers, like, okay, let me write it down. For 52, it is 27 is the answer. For 37, what I said? 1 and 2, right? For 69, I said 4 and 4. This one. For 60, it was 3 and 5. And there is 125, right? 25 is a very good guess. Very good, because it gives a 0 and 0. And you can check 9 and 9, what happens also. Because that is the maximum possible you can make it. Yeah. So if you 9 and 9, what do you get? If you think 9 and 9,
124.
You get 124. So it will be other way. You will think 9 and 9 and you will say 124 to me, and I will tell you, oh, you thought 9 and 9. Okay. So that means there is a kind of a matching, like given these numbers, I can identify what are the two numbers. We have to see like how it is happening. Like just a,
we take the two numbers as x and y.
yes. So now we are going by algebra. Okay. So in this, yes. So 124. So is 124 is 9 and 9. Already we have written. So if you go to 999, then you get 124. Okay. So what you will do? So you assume the first number is x, right? Double it means what? 2x. Then at 5. So 2x plus 5. Okay. Then we are multiplying by 5. And then we are adding y. So this is the expressions you are actually telling me. This is this value you are actually telling me. What is this value? 10x plus 25 or 10x plus y plus 25. So you are telling me this information to me. So now can you guess what I am doing? No. Plugging the value is okay, but suppose I got 37. So this 37 is what? 37 is 10x plus y plus 25. Subtract 25. So you have to subtract 25, right? Yes, first two number is x and y, then yes. So that's why you get 10x plus 20x y plus 25. Yes, right. So that is what we are doing here. So we have to subtract 25. Huh? Yeah, so subtract 25, you get 10x plus y, right? You get the numbers. So if, for example, 25, subtract 25, you get 0, 0, 0, right? If you take 124, subtract 25, you get 99. So you just get the number. So I actually told the both, the why it works and what is the method by this understanding, right? So this is a simple algebra, but this you can actually generalize this problem into little more complex. For example, you can ask, okay, think three numbers x, y, z, and multiply these, multiply that, and etc., etc. And what you will do at the end, you will get 100x plus 10y plus z plus some number, okay, equal to the number he will tell that number to you. You subtract that number, and then you get a 3-digit numbers, and that will be x, y, z. So because you know the 2-digit number can be written as 10x plus y form, and 3-digit number can be written as 100x plus 10y plus z form. Right? So you can make your own magic. If you don't like this, maybe add 2, 5. Okay, you can change it, make your own magic and give it. But here is a issue. Maybe you can ask something. Maybe I am thinking, okay, I'm thinking two numbers, and I double it, okay, then I add 5, then multiply 5, and then I add the other numbers, and suppose I said my answer is 77. So what would be your guess? What two numbers I thought? 5 and 2, right? I said no. I didn't think 5 and 2. I thought something else. How do counter my? I am not disclosing right now. No, you are wrong. 5 and 2. Yeah, 5. If I think 5 and 2, 77 will be the answer. Okay, and I agree. But I'm saying no. I thought something else, not 5 and 2. But I got 77.
We have to prove that only for 5 and 2 will be able to get 77.
Yeah. So there is something called uniqueness. So there is only one solutions. The 5 and 2 is the only one solution. There cannot be any other solution. Because when you write something by 10x plus y, what actually I thought? I thought actually 4 and 12. Okay. Probably you missed the statement that you think between 0 and 9. I thought, okay, 4 and 12. What I did, I started 4. I double it, 8 plus 5, 13.
65.
No, sorry, 4 and 12 is not working. Oh, okay, I have to subtract 25, right? Sorry. So I didn't. No, so sorry, 70, it's okay. Oh, yeah, I thought, yeah.
65.
Yeah, so it's working, right?
Yeah.
So 4 and 12, it should, after subtracting, it is 52, right? So 4 and 12 is also a solution, because 4 into, if x is 4 and y is 12, then 10x plus y will be 52, right? And this is also possible when x is 5 and y is 2. You will tell y is x 5 and 2, I will say no, 4 and 12. So uniqueness is only true if my numbers in between 0 and 9. So that property you have to also keep in mind. Like whenever you write a number in the form of 10x plus y, first of all, we can always write a number in like that, and that is unique. Like there cannot be any other possibilities of x and y, provided that my x and y lying between 0 and 9. This is something called representation, decimal representation of a number. Whenever we write some numbers in 2-digit number or 3-digit number, this is the way we write, right? This is the algebraic interpretation. We all know, but we can make that as a fun, have a magic. So mathematics has a very nice applications. I'm just telling one story, like in the hostel life, like long time ago, like we don't have like mobile that time. We can't pay UPI. We only have a cash to pay something. So the parents give some money just to use it very carefully. Like don't make any unnecessary expenditure, right? So just buy some food or something, right? But what is happening, right? The warden is saying that okay, people are making use of lots of money. Like they are paying, but they are buying so many things. But he cannot get an idea, like okay, how much money they are actually using, say, per week. How much expenditure they are making per week. Suppose there are, say, 20 students in a class. If you ask the question directly, okay, how much money you paid last week, he may not disclose, because he may think, suppose he paid 50 rupees. The 50 rupees that time might be too much. He doesn't want to disclose. No, I will not tell. So if you ask some sensitive question directly, you may not get the answer. This happens many places, even for, say, recently, like exit poll. Like if you just ask to whom you vote, he may not answer. So this type of sensitive questions, you have to somehow mask it. Your question should be in the form so that by such that the answer will be like a mask. Mask means something is hidden or something is suppressed or added, so that it's not clear picture, like whether it's a 50 rupees or 60 rupees. So what the teacher did, okay, you don't have to answer correctly. You can answer whatever you like. So look, there are 20 students, so I have a 20 box. sorry, I have a box with the 20 numbers. Minus 10, minus 9, 1, minus 1, 1, 2, 3, and 10. Okay, I have 20 such numbers. It could be minus 1, could be 1, no 0. Okay. So that these 20 numbers, you are 20 students, you just all of you pick one numbers. Just like a lottery. Pick one numbers, you get your own numbers. Now we add that number to your expenditure and tell me. Okay. Now if he says 60, it could be 50 because he got number 10. Or it could be 70 also because he got my number minus 10. Okay, you can also make it a little higher, maybe minus 10, so minus 10, make it minus 20. Okay, just for an understanding, just for the sake of understanding, like this type of masking, my student may feel okay, but I'm not disclosing exact value. Okay, so maybe the expenditure is not much. Maybe at that time the expenditure is around say 20 rupees, not close to 20, 50. Okay, so expenditure someone has 13 rupees, some others expenditure 10, some 5. Like that, but they are not saying the exact number 13. They are saying 13 plus some number x1, which is one of this. 10 plus some x2, which is one of this. Like that. Okay, they are saying after masking these values. Okay. Now you have all these values, 5 plus x3 and so on. Like you have 20 values. From there you can get total sum. How? Your goal is to get not to individual expenditure. Your goal is to get whether on the average people are making high expenditure or low expenditure.
Adding all the values.
If we add all the values, because they are picking up all these values one by one, like all the values are actually distributed randomly to all 20 students. Okay, you don't know who got which numbers. Okay, but I don't have to know also. You can, after adding the number, you can just throw the paper, right? So if you add all these values, all sums of x1, x2, x3, that will be cancelled to 0. Okay. And then what you get exactly the answer. So this is called some kind of masking. This is nice, simple application of mathematics. Just additions, you are doing some simple addition, masking the values, and you get your answer. So there are lots of fun applications of mathematics. You will, once you know the theory or some ideas behind mathematics, you will be able to apply the mathematics in real life also. Okay. Okay, so now I will do one more thing, then I will stop for today. This is something called multiplications. You know Shokuntala Devi? So why she is famous?
Human calculator.
Human calculator, yeah. So what is human calculator? Like what do you mean by human calculator?
She can calculate or do arithmetic equations and problems.
So she can calculate many multiplications, divisions very fast. In particular, she can calculate the root. She can calculate the root very fast. So what I remember, like there is a 201 digit number, and she was asked to calculate 23rd root of that. A big 201 digit number, you have to calculate 23rd root, not a square root, not a cube root, 23rd root of a 201 digit number. And I don't remember how much time she take, maybe 1 minute or maybe little more than that. Within that, she told the exact answer. That answer is itself like 5 or 6 digit number. Okay. And even that point of time, the computer take more time. The calculator, you have to type the 201 digit numbers and then 23rd root. Typing that will take so much time. So so she was faster than calculator. Nowadays, computer is very fast. You just give the number, whatever calculation does very fast, just quickly. So computation power is too much nowadays. But imagine that point of time, the computer is not good. Even he becomes faster than the computers sometimes. Okay, so that's why she is. It's called human computer, right? Human calculator, right? Yeah. Maybe that point of time, human computer is also okay. Nowadays, I don't know, like this type of thing. But what I like is not that capability. There definitely some biological things she has. What I like, or what I wanted to know, is the algorithm she is using. That was I try to understand, but I didn't get any literature. Maybe I will search for that. So there are two persons also came, two twin possibly. They're doing similar type of things. They came to our institute asking. They have this same similar capability. So I was not present that point that day. So I could have asked them what actually the algorithm they use. So eventually there will be some algorithm. In addition to they have an extra capability of doing some calculations. But there will be some algorithm, some methodology, just not a normal way whatever we do. So there is a normal standard method to multiply two numbers or find a square root or find a cube root, but there is a faster way to do that. Okay, with some information, or if you know something is true for this number. For example, I want to multiply say 23 times 27. I can quickly multiply without doing the normal way multiplications. What will be the answer? The answer will be 621. You can open your calculator or mobile, you can check whether this is right or wrong. So it will be like that. Okay. So what type of numbers I need? I need a number where the first digit is same, like 2 and 2, 7 and 7, and add the last two digits must be 10. So for example, you just tell me two numbers, two such numbers. Any two numbers where first digit, the 10th place number should be same, and the unit place, the sum should be, sorry, is it same as unit place sum should be 10?
86 and 84.
86 and 84. The answer, if you multiply, it will be 7224. We don't have to multiply. We have some formula. So yeah, so what you are saying, the multiply the unit digit. Yeah, so we add one number to this and make it 9 and we multiply. So make it 3, 2 times 3 is 6 and multiply the unit digit. Exactly, right. Now what will be my next question to you? Why this is true? You have to prove me, okay, you got the method, good. I am not happy with the method. I will be happy once you justify the method mathematically. Then I will be happy. Okay. So why it is true? Why, if you multiply these two numbers and you get the answer by doing these calculations? You already know some decimal representation, right? 10x plus y, you do that. You just write down a number, like you have a x in the first digit, y in the second digit, and another number x in the first digit and z in the second digit. But you know y plus z is 10. So you just multiply this expression, these two expressions, what do you get? 100x square plus 10x times y plus z, which is actually 10 plus yz. So this is 10, that means again 100. So 100 times x square plus x plus yz. Now x square plus x means basically x times x plus 1. This is what we are doing. We are multiplying y and z. We are multiplying y and z. And in 100, we have a x into x plus 1. So 100 x into x plus 1 plus yz, right? So this will give 2 digit and this will give after 2 digit whatever you get. X into x plus 1 you get after the 2 digit. Like 100 place and 1000 place if there are any. You may not get always, but you can get 100,000 place also. Yeah, okay. So you can do same thing. not same thing. You can think of, so now I will mostly give some exercise, homework. Think of a strategy for finding square root. Finding a square root, cube root, okay, of a number which is actually square number or cube number, not arbitrary number. Because if I give 26, finding square root will be difficult. 5 point blah blah blah. I can't get it. But if I give say 25, you know the square root is 5. So for a perfect square number, find the square root. For perfect cube number, find the cube root. Find, so there is a you don't know how to get a cube root. We don't study in the school, but we have studied how to get a square root also, right? But that is one option to find the square root. But without doing this, can I quickly find out the square root? If I know that number is a square number, that information is given to you. The number is a square number. Can I make it faster now? Okay, so that's the one thing, one homework. And the final homework, okay, so this is a logical problem that we have a 3 numbers, 8, 9, 6, 9, 8, 3. Note down these 4 numbers, 2, 4, 6, 8, 4, 3. Okay, so there is a lock. Okay, number lock. So that if you press 3-digit numbers, then a lock will open. But you don't know which 3-digit. But what you know, that if you try this, it says exactly one digit is correct. One digit is correct in correct place, right place. Correct in right place. Right place means, suppose the number is 812, then 8 is matching, right? Or 869. That's also possible because 8 is matching, 6 and 9 is not in correct place. Okay, so what is given to you for all these 4 attempt, exactly one digit is correct in place. Okay, you have to find out the number. What is the secret number?
Sir, if 8 is the correct number, then it should be in the first place only.
If 8 is the correct, not necessarily. Why?
It can be 248 also. If 8 is one of the correct number, then the...
So correct number in the right place, you are saying?
Yes.
It could be that you have some number which may be in different place. So if 8 is in the right place, then for all 4 this is true. So it may happen that 8, if 8 is a, so 8 is the first number you said, or?
It can be in the first place or any other place.
Yeah, it can be first, it can be here also. Or maybe 8 is not the number for which it is true. Maybe for some other number it is true.
For the first case, if 8 is the right number in the code, so in the code it should be in the first place or in any other place?
No, in the first place. Like there is a one number XYZ that you don't know, and if you check 8 XYZ with 896, you find exactly one is true, like x equal to 8 or y equal to 9 or z equal to 6. Exactly one will be true. Same thing for if you compare these two, x equal to 9, y equal to 8, z equal to 3, exactly one will be true. Exactly one, not more than one.
In the same place.
Yes, that's why I am saying x equal to 9. I am not saying x equal to 8. X equal to 9, y equal to 8, z equal to 3. Like that, we have a 4 hints you have. For each hint, you have exactly one is true. You don't know which one is true. It's more like a logic question again. Then you have to identify what is the secret. Okay, so maybe we can discuss that in next class. So we have a homework, and this particular homework, we can continue that in next class. You have any questions, you can ask me for just 2-3 minutes. Even in online, if you have any questions, last 2 minutes.
So XYZ are distinct?
XYZ may not be distinct, yeah. It's not given, it's not known. It's not known. It's not known that whether it could be same, it could be different. Yeah. Huh? Yeah. It could be like 888. So if you suppose it is 888, then this is okay, but there is no matching. This is okay. So 1, 2, and 4 are matching, but 3 is becoming false. So that's not possible. So 888 is not possible. Okay. So I think you got the question, because understanding the question is important. Otherwise, it will be like Beethoven ninth symphony. You will do something on some other problem which is actually not. Okay.